So Unit 1, Objective 3, writing equations. So we've really written equations already, same base, but now we are having translations involved, or shifts. So how do we write an equation of a function? That's your essential question. Okay, so linear functions. We have y equals mx plus b. That's for the easiest ones. Most of the time, though, we're going to use this kind of thing. So y equals mx minus h plus k. Okay, this is kind of point slope form, but it lets you use shifts. And h is generally our left-right shift, and k is generally our up-down shift. Okay, you'll see that on the other equations we write. So mx plus b, you notice you could kind of distribute the m, combine like terms, and you get to mx plus b. But why not use this little left-right shift thing and just make life a lot easier? When we're talking about a shift, we always think about from the origin, or the key point, I guess. So our key point, remember, is 0, 0. So on this question, first we need our h and our k. Okay, so we have either 1, 2 or -3, -2. The nice thing about a linear function is either one could be give us our shift. On later ones, we have a key point, the vertex, or on an exponential, the one directly above the absolute or the asymptote. For linears, it doesn't matter. I'm going to use 1, 2 because I like positive numbers better. So from my point 0, 0, that would be right 1 up 2. So y equals mx minus 1 plus 2, right? Minus 1 gives me a right 1 shift, the x minus 1. The plus 2 at the end gives me up 2 shift. And then all I have to do from there is find the slope. Okay, so you have to remember your slope formula. M equals, it's change in y over change of x, y2 minus y1 over x2 minus x1. So I take my 2 points. So I have y2, which is 2, minus -2, which makes plus, over 1 minus -3, which makes plus. So I get 4 over 4, which is 1. I have a slope of 1. So my equation is y equals 1 x minus 1 plus 2, which I would accept that. Or, remember, if there's no number, we assume it's positive 1. So either one would be correct. And there you have it. So the h and k with the shift, that's kind of the new part. The slope, we had to count before anyways. This is a special case. So you got to remember, horizontal, it's going across the y-axis. That means it's y equals 2, because that is the number it's going across. No variables besides the y, or the x. If it's vertical, it's an x equals. Okay, next we have quadratic. So our quadratic equation is y equals a x minus h squared plus k, right? The squared is what makes it the u, the quadratic. Okay, so the nice thing is we have our shift, hk. That's the same as the last thing. So I'm going to do that first, right? We shift from 0, 0. That's our key point in the quadratic function, 0, 0. So I'm going to shift right 4 down 3. So that'd be y equals a x minus 4. That gives me right 4 minus 3. That gives me down 3. And make sure you have the correct form. Quadratics need the squared, basically. Okay. To find a, unfortunately, just like the last time we did this, we have to plug in. We never use our key point, right? Our key point gives us our shift. We have to have a second point. That second point, the non-key point, is what we plug in. So x for 6y, negative 1. So negative 1 equals a 6 minus 4 squared minus 3. There's no shortcut, you just got to do this. Okay, so start simplifying. 6 minus 4 is 2. 2 squared, that is 4, so I get 4a minus 3. I need to solve for a, so I'm going to add 3 to both sides. I get 2, negative 1 plus 3 is 2, equals 4a. And then I divide by 4, and I get 2/4 equals a, which can simplify. So 1/2 equals a. And I just plug that into my equation, 1/2 x minus 4 squared minus 3. There we have it. Okay, so we look at our key point first. So I'm shifting from 0, 0, that's up, oh sorry, left 1, up 3. So y equals ax plus 1 squared plus 3. Left 1, up 3. Then I have to just plug in my extra point. So x, y, so negative 1 equals a negative 4 plus 1 squared plus 3. So I get negative 1 equals a negative 3 squared. Negative 4 plus 1 is negative 3. Negative times a negative does make a positive, so 9a plus 3. So I will subtract 3 from both sides. And negative 4 equals 9a. Divide by 9. This time it doesn't simplify, so negative 4 over 9 equals a. And that is plug that back into my equation. Negative 4/9 x plus 1 squared plus 3. Make sure you have the squared. That's what makes it quadratic. If you don't have the squared, it's very wrong. Okay, let me go back and highlight these equations that we're using. These are important. So that's for linear. This is for quadratic. Remember, h and k represent my shifts. Now we have linear absolute. So we have y equals a absolute value of x minus h plus k. Okay, so that's our general form equation. This is what we're looking at. So we look at our shift first. We shift from 0, 0 once again. The first 3 functions shift from 0, 0. So I'm looking at this. Shifting right 4 up 2. So y equals a x minus 4 plus 2. Make sure you have those absolute value bars. That's what makes it absolute value. So I have a right 4 up 2. Nice thing about this is I can count slope. It's opening up. So that means it's positive. Make sure you remember that. So I'm rising 1, going from 4 to 5, rising 1. Nope. Going from 2 to 5, I'm rising 3. That makes much more sense based on that graph. So I'm rising 3, running 1. So m equals rise of 3, run of 1. Going from 2 to 5, that's a rise of 3. Right, the y values, run of 1. So that's it. Y equals 3, x minus 4 plus 2. Just like linear functions, it's pretty easy once you get your shift down. Okay, so this one's going down. So we got to remember that this is negative. We look at our shift first. From 0, 0, I'm going to my key point. Always going to your key point. So you go left 3, up 2. So y, wrong color. Y equals a x plus 3 plus 2. Left 3, up 2. And then I just need my slope. So I'm going from 2 to negative 1. So that is a down 1, 2, 3. Negative 3 over from negative 3 to 5, 2. Since it's linear, remember we can just count slope. Negative 3, 2, x plus 3 plus 2. Okay. And then we get to our last one, exponential. So we have y equals, so remember this has exponents, that b to the x minus h plus k. Remember, it's not technically in parentheses, but this one up in the exponent, that is our left-right shift. That's why it has the h. Okay, so I'll highlight that because that's going to be an important one. All right, now we got to find our key point. Our key point is always the one just above the asymptote. So you got to find your asymptote, go to that one. Be careful here. I'm actually going to draw this one in because 0, 0 is not my key point. 0, 1 is my key point. So I'm going a shift of left 1, 2, down 1, 2. So y equals bx plus 2 minus 2. Be careful, make sure you're shifting from 0, 1, right, our key point for exponentials. So left 1, 2, down 1, 2. Okay. And then just like quadratics, we can't count slope. Only linear things can we count slope. So I got to plug in. So this is x, this is y. So 3 equals b to the negative 1 plus 2 minus 2. Okay. So we just simplify. So 3 equals b to the first minus 2. Get b by itself, so add 2 to both sides. And I get 5 equals b. Remember, b to the first, 5 to the first is just 5. 10 to the first is just 10. So b to the first is just b. So we have it. B equals 5. Y equals 5. X plus 2 minus 2. Okay, we'll look at one more. So go to the point just above the asymptote. Don't forget, well, they already have the 1, 0 there. That's where we shift from. So from that point, I'm going right 1, 2. Wait, 1, 2, 3. 1, 2, 3, up 1. So right 1, 2, 3, up 1. Okay. Let me use the color. Y equals b to the x minus 3 plus 2. Right 3. Oops, I messed up. See, I shifted from 0, 0 right there. Be careful about that. So up 1. Right 3, up 1. So right 3, up 1. And then I use the second point as things to plug in. There's no shortcut. You got to plug it in. Okay, so I get 26 equals b squared plus 1. Subtract 1 from both sides. So I get 25 equals b squared. So you could square root both sides or think what number squared makes 25. That would be 5. 5 squared makes 25. So 5 equals b. Happens to be the same. It is not always going to be 5. Don't assume that. And there we have it. So next we have combining through adding or subtracting and then graph the new function. Okay, it's actually much simpler than it looks. It says f plus g. You need to literally add them. Okay, take the first one, take the second one, plus sign in between them. Okay, in this case, negative x plus 4 plus x plus 4 simplifies. So I'm going to be left with an x squared. 2 minus 5 is negative 3. And I want you to graph the new function. So this is a down 3 shift for a quadratic. A equals 1, so 1, 3, 5 pattern. So from 0, 0, shift 1, 2, 3. And then I'm going to go right 1, up 1, right 1, up 3. And that will make my u. Okay. Now we have subtraction. So this one is a little bit more complicated, not much. So we have 1/2 absolute value of x minus 7 minus 5. The trick here is, the reason this is more complicated is if this has more than one term, you got to distribute the negative. Change the sign for each piece. This time it was pretty easy. I get 1/2 absolute value of x minus 12. So this is a absolute value function. So this is a down 12. That's terribly written for our sake here. That's fine, whatever. And then our slope is 1/2. Sorry, a, not slope. A is 1/2, but we can treat it as slope. So I'm going to go down 12. I'm going to count by 2s. 2, 4, 6, 8, 10, 12. Wait, 2, 4, 6, 8, 10, 12. Yep. Counting by 2s there. We got to count by 2s for everything, so it's going to be up 1 over 2. Up 1 over 2. Make sure you're careful about counting when you change the scale, which you can do if it doesn't fit. And there you go. There's our function. Okay, now we're going to look at composite functions again. Notice this is coming back. It's probably something you're going to need to know how to do. So it's telling us to plug g into f. So I'm going to get 3/2 x minus 5 plus 3. If you're plugging in a function, or anything really, if you plug in with parentheses, it makes things really easy. Notice, I put parentheses around the x minus 5 when I plugged it in, and I just left it. And that's what we need, right there. So I have right 5, up 3 shift. Oops. With a slope of 3/2. So right 5, up 3, slope up 3 over 2. Don't have any room to go that way, so I can go down 3 left 2. Remember opposite. As long as you do have a line. I know it's linear because it is not squared. Okay. Doesn't have absolute value, and there's no exponents. Okay, last one. This is plug g into f. Plug g into f. Remember, just plug in with parentheses. 4 minus 3x minus 1 squared. Okay, you'll notice this is not how we normally write things. So I would strongly suggest reordering it first. So I'm going to move the 4 to the back, because that's usually where it goes. It's a positive 4. The 3 is negative. Keep the negative with the 3. The 4 is positive, so it needs to stay positive. Okay, this is a quadratic. It's squared with a right 1, up 4 shift. My a value is -3, so that my 1a, 3a, 5a is -3, -9, -15. The first one's really only going to be the one that fits. It's negative, so remember it's going down. So right 1, up 4. And then when I go over 1, I'm going to go down 3. Mirror it. The next one would be go down 9. That's not going to fit. So you got to make sure we make it really skinny, because it can't go all the way over yet. Not quite as good. There we go. And there we have it. So make sure you answer your essential question about how do you write equations. 3 sentences in your summary.